Welcome to Brain Vision.
So let's take a look at some Bronsted-Lowry acid-base pairs and their conjugates. So just as a reminder, a Bronsted-Lowry acid is something that is a proton donor, and a Bronsted-Lowry base is a proton acceptor. And remember what a proton is. You just think of it as a plus, but really it is H plus. H is something, hydrogen has one proton, one electron. If we get rid of its electron, the only thing that's left is a proton because it has no neutrons. Now, when we're looking for conjugates, conjugates share the same stem. They are the same thing, they only differ by an H. So let's take a look at the first one. H2CO3 plus water is in equilibrium with the hydronium ion and the bicarbonate ion. So the first thing you should do is find two pairs of substances that differ by an H. And so if we take a look, H2CO3 and HCO3 minus differ by an H, and the water and the hydronium ion differ by an H. These are our pairs. Now, in these pairs, the acid is the substance that has the extra H. So for between H2CO3 and HCO3 minus, there's an extra H on the carbonic acid. So this is the acid. So what's on the left we call the acid or the base. What's on the right we call its conjugate. When it has one fewer H, like the HCO3 minus, this is the conjugate base. Because it can, remember, a base is something that can accept a proton. So if we go back the other way, it takes the H plus and becomes H2CO3. When we look at water and H3O plus, the substance on the right has the extra H. The conjugate is on the right, so we have the conjugate acid here. And what can an acid do? It can donate a proton. So if we go from right to left and we make some water, then a proton is going to be given up. It's going to be donated. And so water with that one fewer H is going to be the base. Don't get caught up in thinking that water is neutral. So for the most part, water does work out to have a neutral pH by itself, but that's because it acts both as an acid and as a base. In this case, the water is acting as a base. All right, let's do the same thing for our second one. We have the NH3 and the NH4 plus as a pair, and we have the water and the OH minus as a pair. Now, on the left side, the NH3 has one fewer H than the NH4. Fewer H's, that's the base. And if you look at water compared to OH minus, water has an extra H compared to that, so that is the acid. So again, water here is acting as an acid. Now on the other side, we have our conjugates. So the NH4 plus has the extra H plus compared to the NH3. That makes it a conjugate acid. And the OH minus has a one fewer H compared to water, conjugate base. And if you think about it, it can accept an H plus and become water. A base is a proton acceptor. If we go to the third set, we have HNO3 and NO3 minus as a pair, water and H3O plus as a pair. And now we take a look. HNO3 has an extra H compared to NO3 minus. That makes it the acid. H2O has one fewer H than H3O plus. That makes it the base. And of course, then we have the opposites on the other side. So the base, water on the left as H3O plus is now the conjugate acid. And the NO3 minus has one fewer H. That makes it the conjugate base. And finally, we can have our two pairs in the last problem. And so the C5H5N has one fewer H than the substance on the right. That's going to make this a base. The water has an extra H compared to the OH minus. That's going to make water an acid this time. And now on the right, we have our conjugates. We have the extra H on the right. So this is going to be our conjugate acid. And OH minus has one fewer H, so that's going to be our conjugate base.